Hello, good day. This is again mathema. We are doing permutations of distinct and similar objects. So if you haven't seen my previous video about permutations and combinations, I'm suggesting you watch that one first before watching this video. So again, as a review, we have here our type of permutation. So we have distinct objects without repetition, and we use this formula. N factorial is over the quantity of n minus r factorial. And then we have distinct objects. So we have n raised to r. Again, our n is the number of elements, and then r is our how many objects are we considering. And then we have similar objects. So if there are there will be cases wherein, for example, the word mathematics, there will be a repetition of words. So we're gonna make use of this formula, n factorial over p sub 1 factorial. This one here, our denominator, are just the repeated elements. And then when we have circular permutations, meaning to say we are doing, we are arranging things in a circular manner, we're gonna make use of this formula, n minus 1 factorial. So let's have some examples. Let's have A, permutations of distinct objects without repetition. So again, without repetitions, we're not allowed to repeat. So number 1, find the number of ways to arrange 5 different books on a shelf. So again, if this is your arrangement, 1, 2, 3, 4, 5. So first position or place, there will be 5 choices. So we'll have 5, and then 4, 3, 2, and 1. And again, since we're doing permutations, we are just multiplying all those things here. Or this is just equal to 5 factorial. So again, remember our symbol, our math symbol here, factorial. That means to say we're going to multiply downward. So if you have 5 factorial, we're going to do 5 times 4 times 3 times 2 times 1. Excluding 0, of course, because that will make everything 0. So 5 factorial is just equal to 120. So meaning to say there will be 120 arrangements or ways to arrange these 5 books, different books on a shelf. Number 2. In how many ways can 4 students be seated in a row of 6 chairs? So again, in how many ways can 4 students be seated in a row of 6 chairs? So meaning to say we are doing 6 permutation 4. So we're choosing 4 from 6. So this will just give us, this is equal to 6 factorial over 6 minus 4, that's 2. That's 2 factorial right here. And again, we can simply do 6 times 5 times 4 times 3 times 2 factorial over 2 factorial. And again, this one will cancel out. You will get 6 times 5 times 4 times 3. This is 30 times 12. That gives you 360. Alright, or again, you can use your calculator to solve this one. You're just simply gonna look for these buttons, NPR and NCR. Since we're doing permutations, look for NPR. So you will say 6 shift P and then 4. So this gives you 360, the same. Let's do number 3. From 10 candidates, how many ways can a president, vice president, and a secretary be chosen? So again, we have president, secretary, and a secretary, a vice president. So there will be 3. So we're gonna say 10 permutation 3. Or again, this is just what? This is just 10 times 9 times 8. There are 3. We're choosing 3, right? So this will give us 720. You can use your calculator again to check. So say 10 permutation 3. That's 720. Or you can make use the permutation formula, which is 10 factorial over 10 minus 3 factorial. And this gives you 10 factorial over 10 minus 3 is 7, so 7 factorial. So you're gonna say 10 times 9 times 8 times 7 factorial over 7 factorial. And again, this cancels out. You are left with 10 times 9 times 10, the same here. I hope that is clear for our permutations with distinct object. Let's do letter B, permutations with repetition. So, question 4. How many 3-letter codes can be formed from a digits 1, 2, 3, 4, 5 if repetition is allowed? So meaning to say you have here a 3-letter or 3-number code, letter code pero number. All right. Nonetheless, the concept no is the same. So first position, how many choices do you have? You have 5, right? What about the second position? How many options do you have? You still have 5, right? Because again, it says here with repetition, you're allowed to repeat the numbers or letters. And then the third one is just again 5, or this is just equal to 5 cube. All right. So again, remember our formula for permutations with repetition is n raised to r. So this is n is 5 and then r is 3. So you're gonna say 5 times 5 times 5 is 125. That will be our answer for letter B, number 4. Let's do number 5. Here's number 5. A password consists of 4 letters chosen from A, B, C, D, and E. How many unique passwords are possible if letters be repeated? So again, the same thing. You got 5, and then you choose 4, right? So 5 raised to 4. That will be your answer. So this is just 5 times 5, times 5 and times 5. 25 times 25, that is 625, right? So there will be 625 ways or passwords you can create. Number 7, letter C. Permutations of similar objects. So this time there will be objects that are similar. So it says here, how many distinct permutations can be formed from the letters of word level? So if you happen to see here, level has 2 E. So what you do here is you count the number of letters. There are 5, right? 5 factorial over how many numbers or letters are being repeated. So basically you got what do you call this? You got 2, right? There will be 2e. So that's 2 factorial. So this will give you how much? Yeah, letter L as well. So we have 2 factorial, another for L. So this will give you 5 factorial. We know it's 120, right? And then 2 factorial is just 2 times 1. And this is also 2 times 1. So you are just dividing it by 2 times 2. Or this is 120 divided by 4. This gives us 30. All right. Number 7. Find the number of ways to arrange the letters of balloon. So again, how many letters are there? 1, 2, 3, 4, 5, 6, 7. So you're gonna say 7 factorial over. Look for the repeated letters. So you have 2L. So that's 2 factorial. Then you have 2 O's. So that's another 2 factorial. So you're gonna say 7 factorial is what? I'm gonna use the calculator to make it quick. 7 shift that gives me 5040 over, we know 2 factorial is 2, so 2 times 2 is 4. So this gives us how much? Divided by 4, 1260 is number 7. Let's do number 8. Number 8, D, circular permutation. Now, circular permutations are a bit unique because, for example, you have here a circular table. This is your A, B, C, and D. If you're going to rotate the table, for example, this is now D, A, B, and C. These two are actually what the same arrangement, right? You're just looking at it in a different perspective. Here you're looking, maybe this is your perspective, and then the other side, this will be your perspective. But then again, they are actually the same arrangement. So again, when we do circular permutation, remember we do n minus 1. We always set our reference point. So n minus 1 factorial. So, number 8. In how many ways can 5 friends sit around a circular table? So again, when you have your circular table, you always fix a certain individual or an element. So for example, this is your fixed table. So the 4 individuals, the 4 remaining individuals can freely move around the table. So you're gonna say, how many ways can we arrange 4 people around the table? That is just what? That is just 4 factorial, right? That will be 4 factorial. That gives us 24. So again, going back to our formula, that is just n minus 1. So basically, this is 5 minus 1 factorial. That is again 4 factorial, or 4 times 3, that's 12, times 2, that's 24 ways. So again, remember, when you do circular permutation, always set a reference or a fixed point. Let's do number 9. Find the number of ways to arrange 7 different beads on a bracelet. So always remember, by context, a bracelet can be it can be rotated and it can also be reflected, right? So when you rotate a bracelet, that's the same thing as going around. If you flip a bracelet, for example, this one, I'm flipping this out. This becomes D and still B. But since I'm flipping it, this becomes A and this becomes C. So again, these two are just the same arrangement, right? So we are going to divide it by 2. So this is 7. That's 7 minus 1 factorial. But then again, since we are allowed to flip over, we're gonna divide it by 2. So this is now 720 divided by 2. That's 360. Right? That's 360. Yeah, that's correct. That's 360. So number 9 is 360. Number 10. 8 students are to sit around a table. How many distinct seating arrangement are possible if rotations are considered identical? So again, since this is circular permutation, the rotations are considered as identical. So we're gonna say 8 minus 1, 8 minus 1. Wait, that's 8 minus 1. And again, that is factorial. That is 7 factorial. And we know earlier that 7 factorial is 5040. Am I correct? 5040. Let me just use the calculator to check. I think we did that already. Yeah, that's it. That's 5040. Let's do number 11. How many circular permutations can be made from 6 different flags? So again, that is just 6 minus 1 factorial, or simply 5 factorial. This will give you 120. And then 12, 5 people are to be seated around a round table, but 2 insist on sitting together. So the 2 that insist to sit together, you consider this one as one block. So instead of 5, we're gonna have 4 minus 1. Again, factorial. This is 3 factorial. This will give you 6 ways, right? Or 6, 3 times 2. And then this will be your task. You do number 13, 14, and actually 15. Peace.